Welcome guys. Today we are going to discuss about the TCP protocol header format and their advantages and disadvantages. So before this video, we have discussed about the transport layer and the TCP services. So this is continuing video to that particular. Okay, so let's start the TCP segment format. As we know guys that the unit of uh, transport layer is what the segment. So here we need to understand what the segment it is. Okay, and its format. So here the segment format is available, and the segment format having a two fields. The very first is the header, and second is what the data. As we know, guys, in IP format, let's say, or the packet format, we have packets header and the data also. So it mean similarly here also where we have header and data. Now the format of segment is shown in below. The segment consists of the header of 20 to 60 bytes. So size of the header is what 20 to 60 bytes. So minimum it will be 20 and supposed to be 20, and maximum it can be up to 60. Followed by the data from the application layer, because the top layer of this particular transfer is what application. So whatever the data coming from the application layer, that to be accepted by that particular header. Then header is of 20 byte if there is a no option, and it is up to 60 byte if it content option. So this what up to we can extend up to 60 only if the optional feed is set. Okay, if there is a large data is available to transfer to from source to destination, that time only this is going to be extended to the 60 byte. So let's start the header format. Now this header comprise of too many of fields. So here there is a table shown, there is a header format shown. We need to understand one by one each in thoroughly. Let's say what we have in the header format. By first field is what source port address, which is of 16-bit. So we know that the port number is what the endpoint where the application can be run. So source port address is what is of 16-bit, to that is 2 to the power 16 field that contain the port number of application program in the host that is sending the segment. So the process which is running at the source end, which want to send the segment to the destination end, and the size of that port number is what 2 to the power 16, and that address is what the source port address. Second will be destination port address. The destination port address, what this is also a 16-bit field. It defines the port number of the application in the host that receiving the segment. So if this is the sender and this is the receiver, so sender application comprise of the port number. On that port number that application is running, and in order to receive this particular segment, what we have the receiver, and the receiver side also have the port number that is also same size. Okay, that is what the destination port number. Then there is a third field, and third field is what the sequence number, which is about 32-bit. Now sequence number. Before we discuss the sequence number, uh, uh, let's take this this is what the 32-bit field define the number assigned to the first byte of the data containing the segment. What happened over here? As we know, guys, there is a upper layer, that is what application layer, and from the application layer, the continuously data is coming to the transport layer. So here, every bytes are coming over here. Every bytes are coming over here. So this can be a thousand of byte. This can be thousand of byte. Now here, as we know that TCP is a stream-oriented protocol, so he accepts the upper layer data and ensures the connectivity. Each byte to be transmitted is a number. So here, the sequence number is going to be assigned. The sequence number tells the destination which byte in the sequence, the first byte in the segment. Then the sequence number tells the destination which byte in this sequence is the first byte of the segment. Okay, so as we know that continuously data is coming from the upper layer, that is what the byte, and that bytes are converted, or let's say combined into the segments, into the segment, let's say, and these segments can be of any number. These segments can be of any number. So here there can be 5 byte, here can be 6 byte, here can be 4 byte, and these bytes are going to be numbered. These bytes are going to be numbered. Let's say this is what the 10 number, because it is randomly started. It is not necessary to start from 0. So if it started from the 10, so second will be 11, and here somewhere 5 plus is 11, and then 4, let's say 15. Last one is what? 15. 10 is what? 25. Let's say 25. Okay, so 10, 11, 12, 13, 14, 15, up to this. So this is what number. This is what number, and that is number. What is what the sequence number to identify that particular segment, we can say. Okay, a segment number. Here, during the connection established, each party uses the random number generator to create initial sequence number, that is ISN, which is used different at each direction. Okay, so in order, let's say data coming from the application there in terms of the bytes, and that bytes are going to be converted into the segments, and every bytes of that particular segment is going to be numbered, and that is what the sequence number. Okay, so as like to identify that particular whenever the rate transmission is going to be done, wherever the packet loss is going to be done, that time the sequence number is going to be very useful. Then there is a third field, guys, and the third field is the acknowledgement number. This is what also a 32-bit number, that is 2 to the power 32, is very used number. What acknowledgement number it is? It is a 32-bit field. Define the byte number that receive from the segment is expecting to receive from the other party. If the receiver of the segment has successfully received the byte number, let's say X, from the other party, it returns the X plus 1 as the acknowledgement number, and that acknowledgement and data can be piggybacked together. We'll take one by one. So here, if I am the sender and there is the receiver, the sender is sending some data, sending some sequence number, or let's say segment, which let's say having sequence number is let's say X. What is the duty of receiver? Receiver have to reply with this particular as acknowledgement by incrementing the value from X plus 2. Let's say if I'm sending the segment of 10 number, so what is receiver will doing? Receiver will reply with the acknowledgement number is what 11. So this is what the theory, and this can be again a piggyback. Okay, so instead of sending only acknowledgement can be sent with the help of another data, because at the receiver side also there can be a data, and that data can be sent to the sender also. So that piggybacking mechanism we have discussed piggybacking in thoroughly. Okay, that is what the piggybacking. I'm again repeating, sending the instead of only sending the acknowledgement, we can send the acknowledgement plus the data from the upper layer at the receiver, so that the receiver can receive the upper layer data, and that can be sent to the sender also. That is what the acknowledgement number. So acknowledgement number is what the only the positive and negative acknowledgement to that particular that receiver has received that data. Then there is a header length. What the 4-bit field? This is 4-bit field, and indicating that the number of 4-byte word in the TCP header. So as we know, guys, the size of the TCP header is what 20 to 60 byte. Okay, the length of the header can be between 20 to 60. Therefore, the value of field is always to be more greater than 5, greater than equal to 5, because if we take let's say 4 into let's say 4, so it will be only 16. What we have 4 bit, let's say 1 1 1 1, so this is indicating what 15. So 15 into 4, that can be to 60. It is okay, but if I'm setting let's say 0 1 0 and 1, let's say 0, this is what the 4 into 4, this is what the 16, which is not acceptable. So it is going to be, it is supposed to be greater than equal to 5, so that 5 into 4 can be a minimum of 20, and if it is set to all 1, this can be 15 into 4, that is what the 60, that will be acceptable. So this is what the header length. As like the IP header length, we have discussed the same scenario is over here also. Then the reserved bit, the 6 bits are reserved. These 6 bits are reserved, and it is going to be for user purpose. It is not used at, it is going to be reserved for the user purpose. Then this very important field is what the control field, guys. And this control field is about 6 different control fields are available, or control flags are available. One or more of these speed can be set at a time. Out of these 6, that is urgent, ACK, push, reset, synchronization, and finish. Okay, one can be set, and any can be set at a time. This bit is enabled for the flow control, connection establishment and termination, connection abortion, and the mode of the data transfer in TCP. So these every fields are very important for the communication of the segments over here. Now, let's take the very first is what the urgent pointer or urgent flag. This urgent pointer is set to 1 if there is a data available with us, and that is very important. Let's take an example of any letter, or let's say courier, that I want to send that courier in anyhow this within a time. So that is what the urgent data. So out of that, let's say 10,000 bytes. If I have 10 bytes of data which is very urgent, so I can mark this as urgent, and that's supposed to be sent very quickly. Okay. Then ACK. So here this is what the acknowledgement also. This is what the acknowledgement. And here ACK here also there, and ACK here also. This is what acknowledgement number. This is also This is what the acknowledgement number, but this is what the acknowledgement flag, that I am setting this flag to 1. It means what? I am sending acknowledgement, and that acknowledgement number can be something different. Let's say if we discuss x plus 1 as acknowledgement number, so my acknowledgement number is what, the 11. If I'm sending 11 as acknowledgement number, that time before that we have to set the acknowledgement flag first of all 1. Then only we can send the acknowledgement number and vice versa. Those both fields are different. Acknowledgement number is what, the number, and this is what the flag, which is set to be 1. Then push. There another flag is what, the push, and this push flag is what, as we have discussed in earlier videos, that push is what, we are imposing, we are sending some data to the sender without concerning of that particular receiver. Okay, pushing the data. So whatever data is with us, that is what the pushing the data. So in the next slide, what we have also shown that all the here flags. So push is what, the request for push. We are sending the data to that particular receiver. I'm pushing the data. If I have plenty of data with me, I'm pushing that particular data to the receiver. Then the reset. The next is what, the reset. This reset is what the to use to reset the connection. To reset the connection, as we know, guys, the TCP is what, connection oriented, and here the path is need to be established before the terminal, before sending the data. So reset is going to be again used, and this file can be set to 1. Then the connection can be reset. The next flag is what, the sync, that is synchronize. What happens generally in a synchronized flag? The synchronized flag is what, the starting indicate the starting of that particular bit transfer initiation. The sync flag is set only for what, the starting, and the last is what, the fin, that is finalized. This is what the termination flag. This is what the termination flag. When it is set to 1, that the communication is going to be stopped. Okay. So these are the 6 different control fields are available, in that we can quickly glance to this particular slide. So control field is going to be used, which is, there are 6 control fields with each one of your end bits. It can be used for the connection establishment, termination, connection abortion, the flow control, mode of transfer, and there are 6 fields. Urgent field, that is urgent point, urgently need to be data to be sent. Acknowledgement, the push, the reset, the sync, and the finalize. So everything we have discussed. Okay, so let's take another field available in this TCP header. So then what we have, the window size, right? What we have, the window size. This field is define the window size of sending TCP in byte, sending side TCP. Note that the length of the field is 16-bit, which means that the maximum size of window will be to the power 16, to the power 16, which is what 65,535 bytes. Zero form that value. This value is normally referred to as the receiving window, and it determined by the receiver. It means what? Window size indicate what my total capacity and how far I can receive, how far I can accept the size of that. Let's say packets. Let's say if sender is sending, I have a 10,000 of window size, 10,000 of window size. So here 10,000 bit can be accepted, byte can be accepted. If a receiver sending, let's say I have 20,000 of my window size, so here 20,000 can be accepted. Okay, so it indicates that how much data I can accept and what is my maximum capacity of my buffer. Okay, generally what happened in this particular window size, receiver end always announce the receiving capacity to the sender and the vice versa. Only we cannot send the data more than this size because it already initiated at the connection established phase. So window size is very important. Then there is a field that is what checksum. It is a 16-bit field containing the checksum. The calculation of the checksum of the TCP follows the same procedure as the UDP. Okay. However, the use of checksum in the UDP datagram is optional, whereas in the TCP it is mandatory. So it is going to be used for the error control. This is what the checksum. Then the urgent pointer. This urgent pointer is a field. It is what, again, a 16-bit field, which is valid only if the urgent flag is set. We have discussed this urgent flag earlier in the control flag. If it is set that I want to send the data, that is what urgent. The data is what urgent. If it is set, then only the data can be sent at the urgently. It is used when the segment containing urgent data. It defines the value of that must be added to the sequence number to obtain the number of the last urgent byte in the data section of the segment. It means what? Urgent pointer is what? The urgent pointer bit is what, 16-bit. So here urgent data is what ranging from this range to this. Let's say I have urgent data from 10, let's say to 15. So this is what urgent data. If I am having the 1000, byte of my stream, out of this 1,000, only this 10 to 15 bytes are what very urgent. And if these bytes are urgent, that time this urgent flag to be set, that I have set the urgent flag, and out of this 1,000, I have this 40 bytes is what very urgent, that to be sent very fastly. That is what the purpose of urgent point. Then the next field is what the option field. There can be up to 40 byte of optional information in the TCP header, and that time the optional and padding is going to be used. That is, if the size, if the data is more than the that size, that time the optional field can be used. Okay, so these are the all the fields available in the TCP for TCP header. Let's take a quickly the TCP advantages. TCP always guarantee that three things. Very first, our data reaches its destination. It is guaranteed. It reaches there in the time. So time is also perfectly, and it reaches where without duplication. So these are the three things are very much important and very uh, facilitated by the TCP protocol. In the TCP, since all the work is done by the operating system, we just need to sit back and watch the show. So automatically, all these things are going to be done by the operating system kernel. Okay, so we need not to follow the rules. We need not to bother the things what happens in the backend. Okay? Even the debugging is taken care by the operating system itself. This is also advantages. It automatically breaks the data into packets for us. Okay, so whatever the upcoming data is available with us from the upper layer, that is going to be divided into a number of segments, and a segment comprised of what different bytes. Congestion control also provided. The delay transmission when the network is congested. This also provided. The error detection is also provided. In order delivery is also provided, and a retrans. In order delivery is what? Because TCP is the connection oriented, so order is fixed. The sequence is fixed of the segments. So these are the few advantages of the TCP protocol. Let's glance with the disadvantages, guys. Since all the work is done by the operating system, we have discussed. So if there is there are any bugs in the operating system, then we will face many problems. Like problems is surfing and downloading the content from the net. So this is what the rare condition. Okay, 99.99.99 we get the success to this particular scenario. TCP cannot use for the broadcast and multicast connections. So this is what the drawback. It is slower than the UDP because UDP's connection list is faster, and it is TCP's connection oriented, so it needs required to connection established, then transfer, and then termination. So it takes time than the UDP. The bigger header, the fields are more as compared to the UDP. Data doesn't always send out immediately because it takes a time. It takes time because it is what connection oriented. Okay. The side effect of congestion control. This is also the side effects of congestion control, but it's also a rare chance. And the real time conversion will not fill real time as you want it to be. Okay, because this is again the transport connection oriented protocol. It is not that much fast, so we cannot claim that it is what the real time, but it is okay. We have protocol as protocol is 323 protocols are available. All this is going to be available for the session management and the fast nature. Bigger overhead because of the large fields, many fields are available, so overhead can be maximum. And this is example, for example, to send high definition videos, we need to lots of bandwidth. We need a lots of bandwidth. But if we are using the TCP, we need more. We need more because of the retransmission and acknowledgement. Hence, in this case, it makes sense to use UDP than the TCP. So, but obvious, the UDP is connection less, so it is more faster than the TCP. So, in this TCP protocol, the retransmission and acknowledgement will be very much. So we have to wait for the acknowledgement that the receiver has received or not. And if are waiting for the acknowledgement, it take again time. Again, we can retransmit. We can wait. These are the times required to that particular operation. So these are the disadvantages. So in this video, what we have discussed, guys, we have discussed about the header format of the TCP protocol. Every field we have discussed, control field also we have discussed, and there's some advantages and disadvantages. Hope guys this video is going to be understood by you. And before that, we have the transport layer, their services, the port numbers, etc. After this video, we are going to discuss about some every functions in detail, which we have separate video lecture for the every functions of the TCP protocols. Thank you. Thank you.